Hello, here are the solutions to quiz one. I very much hope that you took this quiz seriously. I expect that you did. And in fact, I would like to take it one step further. I would like you to treat every quiz and every homework assignment as if it were a test. Put the pressure on yourself. If you're in sports, if you treat every practice like it's the championship game, you're going to get way better. If you play an instrument, if you pretend that every time you sit down and practice is like you're at the hall and it's performance time, you're going to get better the fastest. So please pretend that this quiz is a test, pretend that your homework is a test, and you'll be amazed how fast you get good here. Let's go over these solutions. Find the domain and range of this function. Okay, so we got a function here, and we are finding the domain and range. Well, the domain, of course, is x values, and you are moving your head left and right. X values are in charge of left and right. Always start with the smallest x value, please, 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 which means you're going all the way to the left, and -3 is the least domain value, and it's included, so you need a bracket. And then you scan to the right. It ultimately goes down and to the right, but ultimately to the right. So it's ultimately going to go to infinity. But I hope you noticed that it did skip over x equals 2. This function is undefined when x equals 2. It has no idea what x equals 2 is. It knows what 1.9 is. It's right here. And it knows what 2.1 is. It's up here. But x equals 2 is not part of the domain, so therefore it's not part of the function. So you'd have to jump over it to express your domain. So this is really everything from -3 to infinity, but not 2. The range is the set of y values. So you're looking up and down, and you start with the smallest, the least value, which is looking down, and -infinity is the least range value. And this parabolic portion covers all the range values of this whole function. This little section has a range value of -3, but -3 is already included with this portion. So you don't have to state it twice. In fact, if you did, that's not correct. You need to be as efficient as possible and don't overstate things. This range is simply from -3 to 0, including. So I'm sorry, from -infinity to 0, including that, because it goes up to 0. Number 2, I like a function that has a domain of all real numbers, but a range of this. There are an infinite amount of solutions here. First of all, a domain of all real numbers. Well, that means it could be a lot of things. It could be a line. That's the first thing that comes to my mind. A line has a domain of all real numbers. So do parabolas. So do cubics. So do the sine function. But the ones we were really working with the last few days were quadratics, absolute value functions, and maybe lines have all real numbers. But the range, one second, the square root, for example, it would be difficult to use the square root function because you can't take the square root of a negative. Now you could be really clever and say, what about the square root of x squared plus 5? That would be fantastic. That has a domain of all real, because no matter what you put in for x, if it's x squared plus 5, it's going to be positive, and you can take the square root of a positive. So the square root of x squared plus 5 does have a domain of all real numbers, but keeping it simple, probably just a quadratic or an absolute value. But you need a range value of from -infinity to 5. Now think about parabolas first. Parabolas begin they have the vertex at the origin and they're facing upwards. Well, that has a range from 0 all the way up to infinity. But if you want your range to be from -infinity all the way up to 5, you have to take that parabola and flip it. So you would need a negative to flip it, to reflect it over the x-axis. And then once it's flipped, you then have to raise it up 5 units so that you include all those range values from -infinity to 5. It does not matter what the shift left or right is. All that matters is if you start with the parabola, you have to flip it upside down and you have to raise it 5. Those two things are necessary. Similar argument with absolute value. Absolute value is the v, and it has a vertex at y equals 0. So first of all, flip it upside down, and now it has a range from -infinity to 0, and then add 5 so that you get your range of -infinity to 5. Number 3, let's start with h. H is a parabola We just discussed this. Parabolas always have a domain of all real, always, always, always. So that should just be hopefully fast and correct for you. F is the square root of a parabola. Now, hold on a second. You can't take the square root of negative numbers. And x squared minus 9, not plus 9, you have a threat of taking the square root of a negative number. So the work, showing your work, convinces me that you know exactly what's going on and it supports your answer. X squared minus 9 cannot be negative, so greater than or equal to 0. And x squared minus 9 factors, x minus 3x plus 3. There are a few ways to think about this problem correctly, but the way we did it in class, which I think is the best way because it's the easiest and the fastest, is to think about that graph. X squared minus 9, x squared is just a parabola, and minus 9 is taking that parabola and moving it down 9. So here's x squared minus 9. And now I want to take the square root of that. Well, you can't take the square root of negatives. So you can't take the square root of any of these y values. So what should the domain be? The domain should be all the x values that produce these y values and these y values. So in other words, every x value from negative infinity to negative 3, including 3 to infinity. And I made another mistake here. This should be, those 3 should be included. Because when x does equal 3, the result is 0, and you can take the square root of 0. So this is the correct answer, from negative infinity to negative 3, including, and then join that with 3 to infinity, including 3. The middle one was definitely the most complicated one. You've got two things working against you. You're taking the square root of something, so you can't take the square root of negative, and you're dividing by something, and you just can't divide by 0. So all those things have to be accounted for in your domain. First of all, the square root. 3 minus 2x cannot be negative, so it has to be greater than or equal to 0. You subtract 3, you divide by negative 2. Remember, if you divide by negative, you're flipping this sign. So you discover that x is less than or equal to 3 over 2, so which is 1.5. So as long as x is less than or equal to 1.5, you're going to be taking the square root of a non-negative. But then you're also dividing by this. So x cannot be 0, nor can x squared plus 5 be 0. Well, the good news about x squared plus 5 is that it's never ever going to be 0. Because no matter what you plug in for x, if you square it and then add 5, it's going to be positive. Because squaring a negative will give you a positive, and squaring a positive will just give you a bigger positive, and adding 5, you're just never going to equal 0. However, x could be 0. I mean, if x is 0, you're in big trouble. So the domain for G is every number less than 1.5, but not including 0. So here is the interval from negative infinity to 3/2, including 3/2, but you're jumping over x equals 0. Without graphing, what's the range of this? First of all, notice it's a quadratic. And you know what quadratics look like. And this went through 3 transformations. It went to the right 918 units. Every y value got stretched by a factor of 2.5. And then every y value went down 310. So can you kind of picture where that parabola is? It's way off into the 4th quadrant, way to the right, 918, and then down 310. But then the parabola is facing upwards because I didn't flip it upside down. It's facing up. So the lowest, the least range value is negative 310. And it goes up forever, goes up to infinity. Number 5, this is not a function. There are 2 domain values that are screwing it up for us. Remember, something is not a function if you have a domain element that goes to 2 different y values, 2 or more different y values. And here you've got people aged 65 in my neighborhood. One 65-year-old has an 11% income tax, and the other one has a 21%. So it's not a function of age to income tax percentage. It is not. You can't depend on it to predict things. And here's the counterexample. Here's the proof. If you have a 65-year-old person, we don't know what percentage they are for income tax. We don't know if they're 11% or 21%. So it's not a function. Age 41 has the same problem. I love number 6. Of course, you saw these problems on Delta Math before. 9, where does 9 negative 2 go? Well, there are 4 transformations here. In order, you should need to go to the left 8. Then you take every y value and you make it its opposite. That's that negative. Then you take every y value and multiply it by 4. Then you take every y value and add 1. The y values are getting a big workout. Everything that's outside this grouping symbol is going to impact the y value. So 4 things. X value to the left 8, multiply the y value by negative 4, and then add 1 to the y value. And you should land on 1 comma 9. Let me double check if I did that right. To the left 8 becomes 1. Yep. Multiply the y by negative 4, it becomes 8. And then add 1 to 8, you get 9. Yep. Number 7. The dashed line, the dashed graph is f of x. How do you get the blue graph? Well, the obvious thing is that there was a reflection over the x-axis. So that means the y values got multiplied by negative 1. And you didn't shift up or down, guys. See, here's the vertex when y equals 0. Well, this blue vertex is also when y equals 0. So that didn't shift up or down. The y value is just reflected. The x values moved over to the left, 1. And then there was also a stretch. So looks like 4 things. So first of all, left 1, which is indicated right here, x plus 1 in the parentheses. A flip, a reflection over the x-axis. So that's why there's that negative. And lastly, did you land on 2.5? I hope you did. How can we find that out? Well, we look at our original. And from the vertex, if I go over 1, I go down 1. But if I go over 2, I go down 2. And over 3, down 3. With this blue one, if I go over 1, I go up 1, 2, and a little bit more. But if I go over 2, I go up 1, 2, 3, 4, 5. So that convinces me that the vertical stretch is 2.5, because in the original there was a vertical change of 2, but in the new one there was a vertical change of 5. So how do I get from 2 to 5? You multiply by 2.5. That's how you get the vertical stretch. And then remember when we checked over here, when you went over 1, there was a vertical change of 1. Well, multiply all the y values by 2.5. Look at this blue one. If I go over 1, I do go up. It looks like 2.5. Last page. All right, the dashed line is 2 to the x power. And notice there's a horizontal asymptote here at y equals 0. The new function has a horizontal asymptote at y equals 3. So that's the first thing that I notice. I don't know what you noticed first, but if the new horizontal asymptote is y equals 3, everything got shifted up 3. So plus 3 is part of your answer at the end. But there's more to it. It's going in a different direction. The left-right direction, not the up and down direction. So the left and right got reflected. That's the x value. So all the x's looks like they needed to be replaced with their opposite. And this is where I landed on. But then how can we be sure? We can really be sure if the equation that we have satisfies these points on the red function. So pick a point on this function, plug it into here, and see if you get a true statement. I chose this ordered pair. That's -1, 5. I'm going to plug in -1 into x and 5 for y and see if I get a true statement. And I did. 2 to the -1 is just 2 to the first. And that's 2 plus 3, which is 5. So that's convincing that this is the correct answer for that red graph. 2 more just like that. Number 9, the dashed function and the red function. First thing I noticed was that the red function is flipped upside down. So that's a reflection over the x-axis. So all the y values got multiplied by negative. So I put a negative right there. And then what else do I notice? Well, it got flipped upside down, but then it also dropped down 1 unit because here's the original starting point, but now my starting point is down 1. So I'm building that. So now I keep my first transformation, the reflection, and minusing 1 drops everything down 1. But I'm not done yet because it looks like it got stretched, and it did. Now, how can you find that out? Just the same old investigation. From the original, if I go over 1, I go up 1. But with the new one, if I go over 1, my vertical changes 2. So that looks like I'm multiplying the y values by 2. Let's just test another one. With the original, if I go over 4, I go up 2. And with my new one, if I go over 4, I have a vertical change of 4. So instead of a vertical change of 2, it's a vertical change of 4. Instead of a vertical change of 1, it's a vertical change of 2. So it looks like I'm multiplying all my y values by 2, which I am. So 3 transformations: a vertical reflection, a flip, which is the negative, a vertical stretch, so the 2, and a vertical drop by -1. Last one, from dashed to solid. The dashed graph is the parent function y equals x squared. How do I get over here? Well, most obviously, the vertex is at 0, 0. This vertex is at -7, -2. That's 2 transformations. That's to the left 7 and down 2. So x plus 7 in the parentheses, -2 outside of the parentheses. Now, was there a stretch? It doesn't look like there was, but let's be sure. If I go to my original, if I go to the right one, I go up 1. Well, that's obvious because it's a squaring. If I put in 1, 1 squared is 1. But in my new function, I go over 1. You see, I go past 1. So it's more than 1. I'm not sure what it is yet. It's 1.5. In the dashed, if I go over 2, I go up 4 because 2 squared is 4. But in my new one, if I go over 2, I go up 1, 2, 3, 4, 5, 6. Okay, so instead of going up 4, I go up 6. I'm multiplying by 1.5. 1.5 times 4 gives you 6. And so here is the final equation. And if you have doubts, good for you. Plug in a ordered pair on this red parabola into your function and see if it works out. Like I would try this ordered pair, -9, 4, and see if I get a true statement. So that is the quiz, and I will see you in class as soon as possible. Hope you're doing well.